Hi guys, today we're going to be talking about writing equations in two variables. So an equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables, meaning two letters, is an ordered pair that makes the equation true. To check whether an ordered pair is a solution of the given equation, evaluate the equation with the given x and y values. You want to make sure that both sides of the equation are equal. So let's try a problem together. We're going to check whether the ordered pair 2, 5 is the solution of the given equation y equals 2x plus 1. Now remember, every ordered pair is really the variables x and y, and it goes in alphabetical order. So 2 is my x and 5 is my y. All I'm going to do is replace the y and the x in the equation with those two numbers. So instead of y, I'm going to use 5. So my question is, does 5 equal 2 times x, which is 2, plus 1? We want to make sure that is a solution. So on the left, we still have 5. And what's 2 times 2? Remember, we have to do our order of operations. So we do the multiplication before addition. 2 times 2 is 4, plus 1. And sure enough, 4 plus 1 is 5. So yes, it is a solution. All right, so there's a couple other things we need to talk about before we try another example. Equations in two variables can be used to represent real-life situations that involve two related variables. We have two different kinds of variables, two different things. We have the independent variable that represents the quantity that can change freely, and the dependent variable that represents the value that depends on the independent variable. So, the independent variable is going to directly affect what happens to the dependent variable. This is much like science class, where you have basically a constant and the other one is changing. So let's take a look. We're also going to talk about tables and graphs, and these can be used to help us represent these equations in two variables. So here we have a table and we have a graph, and we're given this equation right here. We have y equals x minus 1. All right, so we are asked to complete the table and then graph the results. We are allowed to pick any x values that we want. Remember, on our graph, the x is horizontal and the y is vertical. We're allowed to pick any ones we want. Why don't we use, how about 2, 4, and 6? It really doesn't matter. You could pick any ones that you would like. All right, so I just picked 2, 4, and 6. Just numbers I felt like using. So in place of my x, I'm going to use these numbers. And that will help me figure out what y is equal to. So we have that y is equal to 2 minus 1. So when x is 2, y is equal to, well, 2 minus 1 is just 1. So my pair is 2, 1. My x and my y. All right, let's try the next one. So we want to know what happens when x is equal to 4. So y equals 4 minus 1. Well, what is 4 minus 1? 4 minus 1 is just 3. So my ordered pair is 4, 3. And last but not least, using our 6, we have y equals 6, equals 6 minus 1. And 6 minus 1 is just 5. So my ordered pair is 6, 5. All right, the last thing we have to do is put these points onto that graph, and we're going to connect the dots. So the first one, remember, is x and then y. I'm going to go over to my graph and find my x-axis. I'm at 2. And then I'm going to go up to that 1. All right, there's my first point, 2, 1. I'm going to graph my next point, 4, 3. I go over to 4 on the x-axis. I go up to 3 on the y-axis. So 4, 3. And last but not least, I have 6, 5. So I go over to 6, and I go up to 5. 6, 5. The last thing I want to do is just connect those dots. And that's it. All right, guys, time to try the practice problems.